In this video, we are going to define centripetal force, state the agents of centripetal force, and understand what factors affect this force. Now, when an object is moving around a circle with a fixed radius, let me call this radius as r bar. In order to keep this object around the circular path, you need a net inward force, and that force is called the centripetal force Fc. So you can define centripetal force as the net inward force needed to provide centripetal acceleration necessary for circular motion. This is the force that will keep the object in its circular path. Centripetal force always point radially inward. So if this is the radius vector r bar, and I have to draw the centripetal force at that point, it is always pointing radially inward in the same direction as centripetal acceleration. Now, centripetal force Fc is not a fundamental force. It is a pseudo force. It is any force or sum of forces which points towards the center of the circle. So any force in a system undergoing circular motion can be defined as centripetal force if that force or some of the forces are pointing towards the center of the circular path. So let's say if a satellite is orbiting the Earth, it is the force of gravitation between the satellite and the Earth that keeps the satellite in its circular path. So in this situation, the agent of centripetal force is the force due to gravity. Then let's take another example of a car moving along a curved road. When the car is moving along the curve, it is the force of friction between the tire and the road that provides the net centripetal acceleration. So here centripetal force is the force of friction. Then if you take a rope and tie a mass at the end of the rope and swing it. In this situation, the tension in the rope is providing the required centripetal force to keep the object along the circular path. So my centripetal force now is given by the tension in the string. Then if you are in the ride of a rotating cylinder, where you are attached to the wall of the cylinder while it is rotating, it is the normal force that the walls of the cylinder exerts on the person that provides the required centripetal acceleration to keep the person attached to the walls of the cylinder. So normal force can also act as an agent of centripetal force. Then when you have the case of a roller coaster, it is the resultant of the normal force and the force due to gravity that gives you the centripetal force required to keep the object along the circular path. Then in the Bohr model of atom, we assume the proton to be inside a nucleus and the electrons orbiting the nucleus in circular path. The Coulomb force of attraction between the proton and the electron provides the electron the centripetal acceleration to move along its orbit. So Coulomb force here acts as a source of centripetal force. Agents of centripetal force can be any one of these forces or combination of forces, all pointing towards the center. So it could be the gravitational force or the force of friction, the tension in the string, the normal force, the Coulomb force, or a combination of forces. Now, centripetal force can be written as Fc equals mass times the centripetal acceleration AC. And we know that centripetal acceleration can be written in three different ways. You can write centripetal acceleration AC as r times omega squared, or AC as v squared over r, or AC as v omega. Now, in cases where we keep the angular velocity omega as constant, like in case of a carousel or a merry-go-round, in this situation, I can write my centripetal force Fc as m times AC, I will write as r omega squared. Now, only in these cases where omega is constant, the angular velocity is constant. In this situation, the centripetal force Fc is directly proportional to r. That means if you increase the distance from the center, the centripetal force will also increase. So if I had two carousel rides, one with a radius of r1 and the other with a bigger radius of r2. If r2 is bigger than r1 and the angular velocity for both remains the same, then centripetal force for 2 will be greater than centripetal force for 1. Then in situation where we keep the linear speed constant, that means when v is constant. In this situation, we can write the centripetal force Fc as mv squared over r. Now here when the linear speed is constant, the centripetal force Fc will be inversely proportional to r. That means if I increase the distance from the center, centripetal force will decrease. And if I reduce the distance from the center, centripetal force will increase. So we can have two different cases of how centripetal force change with distance r. If omega for a particular situation is constant, centripetal force is directly proportional to r. It will increase when you increase r. But if linear velocity is constant, then centripetal force is inversely proportional to r. Moreover, in this situation, we see that centripetal force Fc is directly proportional to the mass. That means if I increase the mass of the object, centripetal force will also increase. And if I decrease the mass, centripetal force has to decrease. So by whatever number you change the mass of the object, centripetal force will change by the same number. So let's say if I write down changes of masses here and the respective change in centripetal force here, if I double my mass, centripetal force also should become double. If I make my mass 4 times, centripetal force will also become 4 times. If I make my mass half the original value, centripetal force will also become half of the original value. And from this equation, we also see that Fc is directly proportional to v squared, which means that centripetal force has to increase if you increase the velocity of the object. So centripetal force will increase according to the square of the velocity. So by whatever number I change velocity, centripetal force will change by the square of that number. So let's discuss this situation also. Here I will write the changes in velocity and then how the centripetal force changes. If I double my velocity, if I make it 2 times v, centripetal force will change by the square of this number. So square of 2 is 4. Centripetal force will increase by 4 times. Then if I triple my velocity, I make it 3 times v. Centripetal force again will change by the square of this number, so it becomes 9 times Fc. Then if I make my velocity half, again centripetal force will change by the square of this number, so it will become Fc by 4. So by whatever number you change velocity, increase centripetal force by the square of that number. Whereas for the radius, centripetal force is inversely proportional to radius in this situation. So if I increase r, centripetal force will decrease. And if I decrease r, centripetal force will increase. And by whatever number you change r, you divide centripetal force by that number. So if I make my r double, centripetal force will become half. If I triple my r, centripetal force will become Fc by 3. And if you make your radius half, centripetal force will double. By whatever number you multiply r with, divide centripetal force by that number. So this is how centripetal force in situation where velocity remains constant changes with each of the following terms: mass, velocity, and the radius.